This is part 2 of a 3-part series on organizational learning theory. In this video, I address a question that students have often when learning about organizational learning in an information systems class. Students ask, what does organizational learning have to do with information systems? Well, I kind of alluded to this a little bit in the first video. I explained that turbulent, dynamic environments brought on by information technology cause the need for organizational learning. Well, also, in this video, I will make it very clear that information systems support organizational learning. So let's go back to our theory. You'll need to be able to draw this again for the next test. Again, take a sheet of paper, try to draw it. If you draw it incorrectly, try again until you get it right. Everything that's on here. At the bottom, you can see general systems theory, input, processes, and outputs. And at the top you see 2 loops. This is the feedback loop in general systems theory. This diagram contains the same elements as in the first video, so it hasn't changed. So make sure you can draw this. I'm trying to reinforce this theory. So what does information systems have to do with organizational learning? Specifically, do information systems support organizational learning? Let's look at each part of this diagram. First, we look at the technology element. Technology is a very general term. This is the operations or the processes involved in the firm producing a physical product or a service. I've listed here several information technologies that support this general notion of technology or operations or processes. You may be familiar with some of these based on our discussions. First is operating systems. An operating system is the most important software that runs on a computer. It manages the computer's memory and processes as well as all of its software and hardware. It also allows you to communicate with the computer without knowing how to speak the computer's language. Examples of an operating system are Windows 10, Apple's Mac OS, and Chrome OS. By supporting any application the organization uses to support its processes, an operating system supports the firm's operations. Computer systems that support manufacturing also fit in this category. Manufacturing is the production of products for use or sale using labor and machines, tools, chemicals, or biological processing. So anytime a computer supports manufacturing, it's going to support the organization's operations. Computer-aided manufacturing and computer-integrated manufacturing are 2 clear examples of this. Another example is office automation, which refers to the varied computer machinery and software used to digitally create, collect, store, manipulate, and relay office information needed for accompanying basic tasks. An example of office automation is mail merge. Another example of how information technology supports organizational processes is robotics. Robotics technologies consist of all processes necessary to design, build, and maintain robotics and other intelligent machines. Robots are sophisticated, intelligent systems used to assist in physical tasks. Next, we focus on how information technology supports knowledge acquisition. I'll talk about 5 information technologies that support this important element of organizational learning. A point of sale terminal is a hardware system for processing card payments at retail locations. We've talked a bit about transaction processing systems. A TPS is a software system or software-hardware combination that supports transaction processing. This can be the lion's share of business information processing. You've all used search engines. Technically, a search engine is a software system that is designed to carry out a web search, which means to search the World Wide Web in a systematic way for particular information specified in a textual web search query. A meta search engine will utilize multiple search engines. These are 2 additional great examples of how information technology supports knowledge acquisition in organizations. Next, a web portal is a web-based platform that provides employees, customers, and suppliers with a single access point to information. Whereas a search engine contains a field that you can use to type in a search query, a portal is a predetermined series of links to resources users may be interested in before their search. So a portal contains a gateway to information that the designers knew users would be interested in. For example, Yahoo contains a gateway to predetermined searches pertaining to travel, news, and email. Data mining is another important way that organizations acquire knowledge. It is the practice of examining large databases in order to generate new information. So we can look at large volumes of records and calculate associations between the variables in order to cluster concepts, such as the sale of Coca-Cola and umbrellas, something we may not have thought about before, but those two items may be purchased together, and until we do our web mining exercise, we would not have thought of that. So data mining is an important way to acquire knowledge in organizations. It is heavily statistically based. Next, we look at how information technology supports decision making. As you can see, I've listed 8 categories of information technology that support decision making. Management support systems are computer-based systems that are supposed to be supportive of managers, so they support any type of decision made by managers. They're somewhat unique in that they are usually associated with periodic reports, so these were some of the earliest types of information systems to support managers. Decision support systems are a set of related programs and the data required to assist with analysis and decision making within an organization. Decision support systems are different from management support systems in that DSS allows users to make ad hoc or as needed analyses to support decision making. In other words, something may just come up and they need to use a system to support decision making. Whereas a management support system will not have the flexibility to do this, the DSS will. A group decision support system is the same thing as a DSS, except it supports groups, and the technology, the hardware is very different. You may have to go into a room. This process may have to be facilitated by a moderator, and you may have different technology to allow for the group input and anonymity necessary to make good group decisions. Executive information systems are a particular type of DSS just for executives. These systems have to be very user-friendly, but they also have to have drill-down capability to look into any of the organization's databases all over the world. EIS are usually customized for the organization. Expert systems use artificial intelligence techniques. Such systems use databases of expert knowledge to offer advice or make decisions in such areas as medical diagnosis and trading on the stock exchange. Neural networks, or artificial neural networks, are vaguely inspired by the biological neural networks that constitute animal brains. Such systems learn to perform tasks by considering examples, generally without being programmed with task-specific rules. A digital dashboard is an electronic interface that aggregates and visualizes data from multiple sources, such as databases, locally hosted files, and web services. Dashboards allow users to monitor business performance by displaying historical trends, actionable data, and real-time information. Whereas you use a dashboard to support driving down the street, managers use digital dashboards to give them sight when they are trying to manage their organization real time. The management cockpit is a dedicated place for meetings, where dashboards are displayed on each wall of the room, providing specific information from each department within your company. These explanations show very clearly that information technology supports decision-making in modern organizations. Next, we'll talk about how information technology supports incremental change. As I have explained, incremental change is related to the quality revolution. You can research this more by searching for TQM, or Total Quality Management. There are 2 broad categories of information technologies that support incremental change. The first is quantitative. Statistics packages like SPSS and even Excel offer opportunities for organizations to engage in statistical quality control. The other category is qualitative aspects of incremental change. I've listed 6 of these technologies. You may be familiar with some of them. Email, of course, supports the qualitative aspect of incremental change when we discuss through email improving the organization. Video conferencing comprises of the technologies used in the reception and transmission of audio-video signals by users at different locations for communication between people in real time. These investments are made to ensure that communications are rich. Telepresence systems are highly integrated multi-codec, multi-monitor, multi-microphone, and multi-channel speaker systems. The objective of a telepresence system is to present interactive video and audio between locations with near lifelike audio quality and with near life-size video images. Again, the purpose of telepresence is to support rich communications across distances, and you can see from this image it takes a substantial investment. An interactive whiteboard, also commonly known as an interactive board or smartboard, is a large interactive display in the form of a whiteboard. It can either be a standalone touchscreen computer used independently to perform tasks and operations, or a connectable apparatus used as a touchpad to control computers from a projector. They are used in a variety of settings, including classrooms at all levels of education, in corporate boardrooms, and work groups. Also in training rooms for professional sports coaching, in broadcasting studios, and others. As we have previously described, Web 2.0 refers to websites that emphasize user-generated content, ease of use, participatory culture, and interoperability for end users. Customer Relationship Management, or CRM, is an approach to managing a company's interaction with current and potential customers. It uses data analysis about customers' history with a company to improve business relationships with customers, specifically focusing on customer retention and ultimately driving sales growth. All of the examples on this slide show that information technology supports incremental change in organizations, and more specifically, they support both quantitative and qualitative change initiatives. Next, we focus on how information technology supports radical change in organizations. There are two clear examples that I will describe. First, computer-aided software engineering, or CASE, is the domain of software tools used to design and implement applications. CASE tools are similar to and were partly inspired by computer-aided design tools used for designing hardware products. CASE tools are used for developing high-quality, defect-free, and maintainable software. You can see on the bottom left a flow diagram that is used in the development of software. This is just one example of a CASE method. Enterprise resource planning is the integrated management of main business processes, often in real time and mediated by software and technology. We've talked about ERP a good bit. ERP is a suite of modules that support specific business functions. Both of these technologies support radical change in organizations. CASE tools explicitly have the purpose of changing processes, whereas when we adopt ERP, we have to change our workflows to accommodate the new technology. Information technology also supports organizational ideals, or the vision of our company. There are two broad ways in which IT does this. First is through computer-aided design. CAD is the use of computers or workstations to aid in the creation, modification, analysis, or optimization of a design. We are using CAD to design buildings, machine parts, aircraft, automobiles, bridges, artwork, and CAD is used all over the world by engineers to design physical structures. Virtual reality, or VR, is a simulated experience that can be similar to or completely different from the real world. Applications of virtual reality can include entertainment, such as video games, and educational purposes, such as medical or military training. In these two very important ways, information technology supports ideals, and it can support ideals in terms of the end product or a manufacturing process, or even supports learning how to drive a tractor. Finally, we talk about how information technology supports standards. Standards are simply a threshold value or an expectation of how we should behave or perform. It is very important for managers to communicate standards to a group of employees or system users. For that reason, word processors and desktop publishing applications directly support the creation and communication of standards. That concludes our second discussion about organizational learning. I hope that you see very clearly that information technology definitely does support organizational learning. And as I've said in the past, all information technology supports organizational learning. Thank you.